All right, boys and girls, welcome to day 2 of section 4.3. I'm going to start off with example number 6, applying trigonometric identities, and you can find that on page 277. So I'm doing the checkpoint. According to the checkpoint, they basically give us theta, which is an acute angle, and they tell us that tangent of theta equals to 2, and they want us to find the values of cotangent of theta and secant theta. Okay, so cotangent of theta and secant of theta. Okay, so here we go. So this is when you use your trig identities on page 276, or hopefully you created them in a flashcard, because you do have to refer to them often. Okay, so if I'm given tangent of theta equals 2 and I'm looking for cotangent, then most likely the trig identity that I would use is the one where is given that cotangent equals 1 over tangent of theta. Okay, and we have tangent of theta. Tangent of theta equals 2, so I would literally substitute that with 2, and we have 1 over 2. Okay, so according to the identities, cotangent of theta equals 1 over tangent of theta, and I substitute 2 for tangent of theta, so I just get 1/2. Okay, and that's it. All right, moving on to the next one. Secant of theta, if you kind of look, if I'm given tangent and cotangent, the only one that you can really use is the trig identity 1 plus tangent square of theta equals secant square of theta. And I've gotten the question asked, how do you know which one to use? You'll know depending on what's given. Okay, so since I'm looking for secant and I'm given tangent, then this would be the best one to use. Okay, so depending on what you have and what's given. So we can substitute tangent square of theta by putting 2 squared. Okay, and then of course 1 plus 2 squared is 1 plus 4, or just 5. And this is secant square of theta. But I'm not looking for secant squared, I'm just looking for secant, so I would square root both sides, and I would get square root of 5 equals secant of theta. Now, if you're wondering, Miss Frias, can I get a decimal? Sure, you can get a decimal. If you do that, then that means I have to pick up a calculator and write square root of 5, which gives me approximately 2.23, and just depending where you want to simplify, where you want to round off. Okay, so it just depends. I can leave my answer this way, and I actually like my answers this way because it's more of an exact value. Okay, so again, if you want to write a decimal, all I have to do is just pick up a calculator. But see, this way I don't need a calculator at all. Okay, all right, so I'm actually going to do one more with you from example 6 because it's a little bit different. Okay, so let's move on to the next one. Okay, so the next one that I'm going to do with you is what I call the extra example in 6. And same thing, we're given let theta be an acute angle such that sine of theta equals 1/4. And then they want us to find the values of cosecant of theta and cotangent of theta using trig identities. Okay, so here we go. If I'm given sine of theta and I'm trying to find cosecant of theta, then I would use the one that says cosecant of theta equals sine theta. Okay, so I am given sine of theta, which is 1/4. So I would just write 1/4. And of course, we have a fraction divided by a fraction. So remember the rules. You're basically multiplying by the reciprocal of 1/4, which is just 4. So it'd be 1 times 4. So just give you 4. Okay. And then for the second one, cotangent, I would use the trig identity, the one where you're using the Pythagorean identities. So the 1 plus cotangent cotangent square theta, equals cosecant square theta. Okay. And that's because I found what cosecant is, and I'm looking for cotangent, so I have everything that I need. Okay, so this would be 1 plus 4 squared. Whoops, actually, and not here. Sorry, I got ahead of myself. Cotangent squared theta and cosecant, that's 4 squared. Okay, sorry. So this would be 16, and I'm going to subtract 1 to both sides. Okay, so this would be 16 minus 1, which is just 15. Okay, so this is cotangent square theta. Okay, and then we're not solving for cotangent squared theta, we're solving for cotangent, so square root both sides. So cotangent of theta equals square root of 15. Okay, if you want to find a decimal, that's up to you. You just pick up a calculator, but again, I could do all of this without a calculator, so I would just leave it in this form. Okay, all right guys, now you can either pause and try the example, or we're going to continue to example 7 because it's just a continuation. Okay, so it's an extension, so I'm going to keep going. All right, boys and girls, now we're moving on to example 7. It's still using trig identities, but now it's a little bit different. Okay, so the one that I'm going to do with you is checkpoint, and basically it says use the trig identities to transform one side of the equation into the other. So all we're really going to do is just simplify. We're going to try to see if we can get it so that the left hand side matches the right hand side. Okay, so it can be a little bit tricky, but to be honest, I'll kind of give you a hint as how I would do it as a student. Okay, so here we go. I'm given tangent theta times cosecant of theta. So again, you either look at your index card or the book on page 276. Okay, well, here's a couple of hints. So I look at the book and I know that tangent of theta is 1 over cotangent of theta. And if you look at the book, you also have another choice. You also know that tangent of theta is also sine of theta over cosine of theta. Okay, so again, I'm going to just write these all out just so you know. And then I'm also given in the book that cosecant of theta is equal to 1 over sine over theta. I'm sorry, 1 over sine theta. Sorry, not over. And we know that secant theta, it's the same as 1 over cosine theta. Okay, so this is the same as 1 over cosine theta. Okay, so you kind of have to think ahead. Okay, you have to think, which one of these will I use and what can I eliminate? Because you can either keep this or use this. Okay, and you can either keep this or use one of these. But if I know that I'm going to have 1 over cosine of theta, if I replace tangent of theta with sine over cosine, and I use cosecant 1 over sine, I can get the sines to cancel, and then I'll left with cosine. So you kind of have to plan, okay? And I'm going to use these two. So now let me show you how I would use them, okay? So now I'm going to replace tangent of theta with sine of theta over cosine of theta. And then I'm going to replace cosecant theta with 1 over sine theta, okay? And then once you look here, you can tell that you should be able to cancel the signs. They'll cancel each other out. So you're actually left with 1 over cosine theta, which secant of, let me move this up, sorry, which secant theta is the same as 1 over cosine theta. So now you manage to get the left-hand side to equal the right-hand side. Okay. And that's it. It's just a matter of playing with your trig identities, okay? So now I'm going to do one more. Okay, so I'm not going to do the checkpoint B because I think I'm going to let you guys do that, but I'm going to try this extra example. And again, we want to verify that cotangent square theta equals 1 over sine square theta minus 1, okay? So here we go. Cotangent square theta would be similar to Okay, so cotangent square theta, if I look at the trig identities, and again, sometimes it's just trial and error, guys. I'm going to go ahead and use the Pythagorean identity. The 1 plus cotangent square theta equals cosecant square theta. So if I solve for cotangent square theta by itself, I would end up with cosecant square theta minus 1. Okay. And then I'm going to look at cosecant. And if I look at cosecant, I can use the one where 1 over sine theta. But since we have cosecant squared, then that means I can square this. And if I square 1, it'll just be 1. And if I square this, it'll be 1 over sine squared theta. And guess what? And then I could just subtract 1, and now the left-hand side matches the right-hand side. Okay, so that's it. Okay. By the way, there's often more than one way to do these, and sometimes it's just trial and error. You have to just pick the right identity and simplify it into C. And if it doesn't work out, then you just have to use another property. Okay. So there could have been more than one way to solve this one, but this is how I solved it. So as long as the left-hand side matches the right-hand side, which it does, then you're good. Okay. All right. Now I'm going to give you guys a couple problems to try on your own.